Hi, welcome back. I'm breaking down a sheet of 2mm mild steel sheet metal to a more manageable size because I finally want to make a cross-slide cover for the new lathe. At this point I have the neoprene material covering the bed, but when I crank the cross-slide in far enough, the scraped ways here get exposed and all sorts of crap fall down onto it. So I figured I'd make a piece of sheet metal like this without this cut here. This is just so I can test fit without removing the compound. And this wraps around the cross-slide like this. It covers the scraped ways, protects them, and also creates a secondary barrier here on the side so chips don't migrate into the ways from the side. And over here it gives additional protection to the linear scale. That's the basic idea. We won't lose any mounting capability up here on the cross slide. There is a number of threaded holes in here. Some are for, well, what are those for? Some are for the tracer attachment or a taper turning attachment, and some are for mounting a mill table onto it, a T-slot table, so you can use a milling attachment on this machine. I'm not using either of one, but there is always the option. Or if I want to put a second tool post on the back of it, then I can still use those threaded holes in here too. They're just plugged up with some set screws at the moment. So that's kind of what I want to make. I'm going to center up on this piece of sheet metal and just remove everything that's too big later. So kind of here, here, here and here. Now I changed to a finer tool to do my layout lines. A fine pencil usually works quite well on sheet metal. So we need a line here. I mean, all the layout lines are just for reference. The real dimensioning will be done when I do the cutout on the milling machine using the DRO mostly, or more precise measuring instruments. But I like to have layout lines in general, so I know what's going on. I think the travels on my milling machine on the decal are big enough to remove all of this material in one setup. This should be 117 by 280 millimeters. And as I mentioned, the sheet metal is regular mild steel. I'm not worried about rust because I'm running oil on this machine. Things I'm not worried about in the least: rust. Okay, that's the cutout. Let's clamp it up on the mill and see how we can remove this material. For a second I was considering roughing it out with the jigsaw, or yeah, I'm going to rough it out with the jigsaw. and then mill it to final dimension. Of course, there is a video of a certain person, practical approach to milling sheet metal, but also very practical approaches to cut very close to a line and then mill it to finish dimension. Always considering what you want to do. Since these are fairly long distances, sawing and milling to the line or to coordinates will be more practical. So that's a lovely cutout. The mill will clean that up. I tried the anchor loop. Greg LaRoche sent me this and I have never used it before. It has a weird smell to it, to be honest. I can't nail it down what it reminds me of, but it's weird. But it seems to work. Don't want to use it on the machines, of course, because I don't know what it does to the oil in the system I have. But for like drilling with a cordless drill or using the jigsaw, I will give it a shot. Thank you. Put it down on the milling machine. I have it clamped down onto some pieces of plywood. People mentioned in the last video that MDF would be a better substrate or sacrificial surface, and I agree. It's usually flatter and more consistent in thickness. But I would also point out that something like scrap aluminium works even better. Cast aluminum plate with the milled surface like Mike 6 or Fortol or C250, whatever the trade name of the cast aluminum plate you buy is, works extremely well as a sacrificial plate since it doesn't melt and burn compared to plastic or wood. And it's very consistent and thick. I used some very long parallels to clamp down the sheet metal on its entire length. And I'm just tightening the bolts to final torque. I roughly aligned the travel of the machine with my pencil layout lines. Once it's milled, the cutout will be my reference of which I do all my dimensioning for outside dimensions and the bends. How did I align it with the travel? Easy. I have a tool with a point in here. In this case, it's a spotting drill. And I bring it down so it almost touches the work, and I kind of eyeball it onto the pencil line. Then I just use the machine power feet to run down the pencil line, and I adjust it. I move the part around with a soft-faced hammer until it stays in line with the tip of the tool. And that's how I got it aligned with the machine. Changing to a normal Cat 40 tool holder because the collet are so short that it requires me to use the quill extended very far, which I don't like. So getting the collet and the reducer sleeve out of the spindle. And yes, 40 taper does not fall out of its taper on its own. It's not a self-releasing taper. I do not know where this myth is coming from, but it is that, a myth. I'm going for a hydraulic tool holder here, because this is relatively long. It's longer than my yard collet chucks, which normally is a bad thing, but in this case, when working directly on the table surface, a little bit of extra length doesn't hurt. I'm using a 4mm 4-flute carbide end mill here. The hydraulic chucks are quite nice because you just tighten them with a Allen wrench, and they run extremely true, are very stiff, dampen out vibrations, and are overall just a nice tool holding solution. So let's see how a little bit of quill extension won't kill me, but I think I can do without. I'm limited by the C-axis bellow on this machine. Once the bellow gets crushed too far, you can't raise the C-axis anymore. Since I removed most of the material with the jigsaw and didn't have to do a full slotting cut with the end mill, cutting the full thickness of the sheet in one go was not a problem. Problems only occur once you try to do slotting with an end mill and sheet metal. Then all the negative effects that I showed in the sheet metal milling video will occur. But still I got a little bit of a burr, but this will knock off quite easily. Pulled the compound slide of the machine, and I'm test fitting the cover here, and it's looking pretty good. It's a snug fit on the outside dimensions of the cross slide. Overhang to the front is pretty good. I will just clean up this edge and leave it like that. I will have to do a little bit of milling to clear the bearing block of the crank here. As you can see, it's hitting the top, so I'm going to notch it out a little bit. Thinning down the sheet metal will not be enough. The backside will get a little bit shorter probably. This side needs to be shortened too and bent downwards. For one, it adds stiffness to the sheet and also straightens it out. If you add one bend, the direction of the bend will straighten out the sheet metal, which is quite nice, and make it incredibly stiff. as if the 2mm sheet needed any help. And also it adds protection from this side against chips and dust. This side also will get cut to about here and then bent downwards. A good sheet metal worker can cut extremely close with a bent shear, but I prefer to cut close and then mill to finish size in this case, because this is kind of a precision component. I want it to look neat, and I'm just not a sheet metal worker, I'm a machinist. Sheet metal workers are magicians. I set up the part on the mill to cut this rear side. I have some precision keys in the T-slot here. They are all ground and close fit in the T-slot. Some blocks here to get some height off the table. Sheet metal is again on some plywood. And I use 2 strap clamps and a large parallel to hold the sheet metal down and keep it from vibrating. And now I can take my cut along the back side here. Yeah. Until I did my final deburr, I'm not really keen on touching this. I'm rather careful. I'm not a huge fan of these deburr tools. They tend to, well, sometimes they work excellent like on sheet metal. Sometimes they tend to just chatter and just be a mess. On really high-end parts, these are quite nice to create about 500 euros of damage per minute. So not a huge fan. I mostly use it for sheet metal work, not on real parts. Well, sheet metal can also be real parts. I mean like customer parts. Since I don't own a bender for sheet metal, I decided to try something that I have seen quite often, and that's scoring the metal with a saw blade to about half its thickness and then just fold the metal like you would bend paper, fold paper. I have the sheet metal clamped up against the vertical apron of the milling machine, and I'm running a 1.5 millimeter wide saw blade on an extended arbor. This worked out better than trying to do it with the horizontal spindle because I can't get the table of the machine far enough up without removing the bellows to use it in that configuration. So removing the table was the easiest solution here. And I'm taking the 0.75 millimeter deep cut in one clamp cut pass. To do the actual bending or folding, I clamped some large parallels to it to evenly bend it across the entire length. Here I'm moving the parallel a little bit inwards because I get into some clearance issues with the clamps on the smaller part that gets bent upwards. This is a very, very improvised setup, but in the end I got extremely clean bends that made me very happy. So I think I mentioned it before, but if you don't own large parallels like these, get some. Try to source them. Sometimes on the used market they show up. People usually made them themselves because this is not exactly a catalog item. So rearranging the clamps once again. This is a little bit finicky. Larger Bessie clamps would have been nice too, but came out quite good. I wouldn't want to do more than one or two with this technique, but it turned out nice. It needed some adjustment for the 90-degree bend in the end, but came out really nice. After bending both of the sides on this cross-slide guard upwards, it's time to test fit it. It's a nice snug fit on the cross-slide, and I don't think that it will need much in ways of mounting it. I might do 2 screws here, but to be honest, it might just be a press fit on here. It looks relatively clean. I will hit it with a random orbit sander once I'm done to clean out all the scratches or to create a random scratch pattern. But that will have to wait until I have everything else done here. The corners here get chopped off so I don't cut myself here. Everything needs a better deburr still, but the fit up is really, really good. The bending by scoring the metal and just folding it over went extremely good, and the bend lines are super clean. This is what I would expect of a high quality box and pan brake. If I was really worried about weakening the material, I think I could either do a few spots of silicon bronze welding wire or just silver solder the entire gap along the length and make a little bit of a fillet in here. I think that would add an immense amount of strength to the bent part, but I don't think that's an issue. On this side I have my 3D printed holder for the bed cover, and the sheet metal reaches completely over the 3D printed part, so hot chips won't melt into the 3D print anymore, which is nice. I was considering to make it out of aluminium, but I don't think it's necessary as far as I can tell. If it holds up to the oil, which usually PLA does pretty good, I will just leave the print in here, and the small lip here wraps around the end of the 3D print here and creates almost like a labyrinth seal. On this side, when I take it off, You can see that we have the linear scale and the mounting bar, and the cover also wraps around the linear scale here. So I did this with very little clearance. When I get some light in here, there is like 1.5 to 2 millimeters of gap between the linear scale and the cover. And over here on the other side, the gap between the 3D printed part and the sheet metal also is very, very small. So there is not much way of dirt getting in from the outside on both sides. So I'm very, very happy with it. And just to see how it looks with the compound slide on here, also make sure this, lost the washer. Well, that's with the guard in place and with the compound on top of it. And we still have full capability of swinging the compound around without any problems. Can't swing it around because the screw and the T-slots just dropped down. But you get the idea. So I think for now I will leave it like that. I will just do some deburring and we will see how it behaves over time. Coolant nozzle can go back in place. So the bedway cover material is a nylon fabric with a neoprene overmold. This is real material for way covers. Comes from an Italian company. I will show the data sheet and the manufacturer later. Problem is you cannot get this in small quantities, most likely, and also they do not sell to private individuals. In the US, you can buy the same material from McMaster-Carr. Look through Robin Renzetti's videos. So he will, somewhere he will, probably in the comments, he will mention the McMaster-Carr product number. I don't have the McMaster-Carr number because I can't purchase there, since they don't ship outside the US for most people. So an alternative to the way cover material is this stuff. This is a permanent or reusable baking foil. This is extremely thin. It's like 0.15 millimeters thin. It's a glass fiber fabric and has a Teflon coating. I used this on the MCO for the last few months, and while it's not as durable, it works very well. It holds up extremely good to all chemicals, but it's bad at withstanding mechanical impacts. If you drop, for example, a wrench on it, it will puncture it. But it works very well. A third alternative is thin leather. I used that on the MCO in the beginning and also on my very first lathe that I showed here on YouTube. That was all leather. And leather is really working very well too, but it gets kind of slimy with the whey oil over time. So there are alternatives if you can't source material like this. Don't use any thermoplastic that will melt and burn like PVC. So to mount it to the bed, I 3D printed a part that looks like this. It has two flexures here and a little bit of a hook down here, so you just snap it in place. This was the first iteration, and the problem is it didn't go all the way back to the headstock because it hit the cover of the gearbox back here. Also, it was too loose. But it already had a clamping latch in here. So it has a number of threads here and like a gib that's pressed down with a number of screws to clamp the bedway cover in place. So that was first iteration. And here's the second one with a cutout in the back here. It's wider in total and a cutout here to clear the cover of the gearbox. This also snaps in place. It's a little bit tighter. And this moves all the way back towards the headstock. Also, instead of tapping the 3D print, I have used heat set threaded inserts that are molten into the PLA. The gib goes on top here. The gib is also 3D printed. I will see if it holds up over time, otherwise I can still make the entire assembly out of aluminium. But if it holds up, I don't really see a reason to remake it. And the black looks okay. Okay, get all screws in place. And I can slide the material between the holder and the gib, or the clamping bar, or whatever you want to call it. And I start to clamp from the center. That way the material shouldn't wrinkle or something weird. There we go. Oh, missed one. And I know there are solutions with bellows or with roll-up conveyor style way covers, but I found this to be the most dead simple and easiest to replace. These will wear down and break and get holes over time, and you want a system that's easy to replace and doesn't require a huge maintenance program. And this kind of works. This works for me extremely good. The way cover material or whatever material you use kind of bunches up in front of the carriage. With the setup that I have here now, I don't lose any carriage travel. There is still a gap here, and I don't lose any travel to the right of the bed. So I think I'm happy with how this looks now. Okay, here is the data sheet for the way cover material. It's 0.5 millimeter thick, polyester textile material and a neoprene overmold. Here are all the technical specs, including the temperature resistance, and here is the manufacturer, PEI. It's an Italian company. That's the material as it comes on a roll. I haven't even checked the thickness, and it's exactly 0.5 millimeters. And this is what real machine bellows, for example, are made out of. Just doing some deburring and corner rounding with some 180 grit emery cloth. All of these edges and corners need to be so smooth that you can touch them at any time and not cut yourself. We all know that one guy who makes stuff that's hazardous to touch. I stole this from an unsuspecting woodworker. Random orbit sander with an 80 grit Abranet. See how this goes. And This is really, this works way better than it's supposed to. I know that a lot of people use double action sanders in sheet metal work, but hey, I really like this. I really like the random orbit sander finish on here. 80 grit is more than fine enough. I'm not going, I also have a 180 here, but this will, it's all mounted on the machine. As by now it's a press fit on the cross side. Well, press fit is, well, it's kind of a very snug fit. No, it won't deform the cross slide. And we'll see. Maybe I have to add mounting screws, but I don't think so. Covers the entire travel of the machine. No exposed ways anymore. Time will tell. Reconditioned machines' ways are too much work or too much money to just have them cobbled up by chips and dust and things like that. Covering machine ways is a very, very good solution to slow down the wear rate on a machine. There are very simple ways of increasing the lifespan of a machine tool. First of all, oil. Oil is the cheapest maintenance of all. Secondly, cleanliness. Third, keep way wipers in good condition and cover ways and slides as good as possible. That's the three main ways of getting more life out of a machine tool before you have to rebuild it. When I see people sanding on a lathe and not having anything on the lathe bed, well, it's no surprise that a machine tool will wear down faster. Or if you cut cast iron and cut through the, for example, on continuous cast bar, you have the outer crust, the scale, you cut through that and you just let that drop down on your ways. That will wear a machine tool way faster than having clean ways and way oil on them. So machine tools are expensive. Do what you can to maintain them. Yeah, of course it's a tool and it will wear out and it has to pay for itself. But still, this machine or any machine tool costs a lot of money, and make the most out of it. Hope you enjoyed. A little bit of sheet metal work here. Thank you all for watching, and I'll be back.